Welcome, everyone, to the ASME Dynamic Systems and Control Division podcast series. I'm your host, Shrestha Rajakumar Deshpande, a research engineer at Southwest Research Institute in their Sustainable Energy and Mobility Directorate. I am super excited to have Dogan Sumer on the podcast today. Dogan and I have known each other for a while now, starting from our time at Ford Research. And Doan now is the senior manager of automated driving at the Hyundai America Technical Center, or HACHI for short. Doan, welcome to the podcast. Would you like to provide a brief intro to our audience today?
Yeah, well, thank you very much, Shrestha. It's very nice to see you. We saw each other quite frequently in the past. Now we are no longer working at the same company, but it's very nice to see you again. And I'm very pleased and I should say honored to be invited to this podcast. So for our audience, my name is Dogan Sumer. I am, like Shrestha mentioned, the head of automated driving department at Hyundai America Technical Center. Previously, I was at Ford, Research and Advanced Engineering, Advanced Control Methods. I was a technical expert and a supervisor. And my background is in control systems. So I got my Ph.D. from University of Michigan Ann Arbor in Aerospace Engineering Department, focusing on adaptive control. I worked briefly for 3 years for Whirlpool Corporation, working on adaptive systems, online learning, Kalman filtering, and all that stuff for state estimation. And then I moved to Ford. At Ford, I first looked into more things like powertrain calibration optimization type of work. And then I switched to ADAS, Advanced Driver Assist Systems. And then I have been in that domain in the last 5 years or so. So thank you very much. This is the introduction. I'll leave it to you, Shrestha, to ask me questions and we'll see where it goes.
Thank you. Thank you for providing that intro, Doan. And so it seems like both at Whirlpool and at Ford, your role was largely to be like a hands-on researcher. So what have your thoughts been on the shift from being that sort of hands-on researcher to now a more technical and people leader?
Yeah, that's a very good question. Thank you very much for asking because, yes, so I mean, first of all, you and I mean, we have PhD background. And so when you do a PhD, your responsibility is typically to solve very difficult problems and also sometimes niche problems because you have to advance the field. And to advance the field, you cannot really work on a problem that most people have looked at. So typically you will see PhD dissertations titles to be very specific. And we are, generally speaking, PhD people, I think, get the most joy out of solving problems themselves as an individual contributor. So you are the happiest if you can figure out how to solve a problem that no one was able to solve before. And I think that's the mentality of a researcher, technical expert. Now, when you become a leader, or so in my current role, I'm a senior manager. And also last 4 or 5 months at Ford, I was a supervisor. So I was starting to transition to more of a leader in terms of people leader. And the biggest difference I have seen is to motivate yourself to have your people solve problems for you. So get work done, not yourself, but through either hiring smarter people than you or enabling your people. Of course, you will provide technical expertise that you had from the past. Of course, you will, brainstorm together, but you are a successful leader, in my opinion, if your people develop new concepts, new technologies, new software that advance the field. I think one of the biggest failure modes of technical people with PhD backgrounds that turn into managers is not being able to remove that hat of Okay, I need to be the smartest person. I need to solve the problems. So from that regard, I think communication with your people, your empathy in terms of what your people like doing most, and giving them, delegating the type of tasks that are well suited for every individual in your team is the one of the more important things.
Hmm.
I would say another, maybe tying back to what I was saying earlier, you have to have a bigger grasp on the bigger picture. I think there's a saying like if you stand too close to the elephant, you don't see the elephant. As PhDs, we are trained to stand too close to the elephant because we're solving specific problems. But as a leader, I think you need to stay away or stand a little bit farther to see the bigger picture, which means now you will sacrifice possibly not understanding the details as much as you would like. But that's the trade-off that I have experienced.
That's very interesting. And that makes me think of a follow-up question, which is, do you think a non-technical background
Mm.
would lend that person to be a better people leader than
Mhm.
someone with a deep technical expertise? Or do you think a mix of the two is really what you want?
I think that's an excellent question. Looking back, I think one of the most successful or best people leaders I had in my career was not that strong technically.
Oh,
But
really?
when it came to the actual
Wow.
technical elements of the position, um, he was not as strong. And there were stronger people than him in terms of understanding the technical details, but he was one of the best both business leaders and technical leaders that I've ever worked with. So I have that example, but that's just one example. In my opinion, the best maybe would be someone who has the both. But of course, it's very tough to find that type of a person. Um, so it's a very difficult question, Shrestha. I think having technical insight, technical knowledge is definitely extremely helpful. So I will not say that, the technical people shouldn't be leaders, but I think when you become a leader, there are more important talents and there are more important, I guess, personality traits than the technical knowledge itself.
Well, that makes a lot of sense, Don. Thank you for your insights on that. And I think reflecting on a combination of your sort of experiences through your journey, sort of segueing from that, how would you approach an advanced control design problem in an industry
Mm.
setting compared to academic research? Leaning upon your experiences through your doctorate program in industry, and at Ford, you had a lot of collaboration with academia.
Yeah. Interesting. Again, very interesting question. So it's, I think, a little bit dependent on the type of position you have. You can still be in the industry, but if you're in a research lab or if you're in a research and advanced engineering type of organization, I think it's a little bit dependent on what the objectives of your department or yourself are. I will reply to this question based on the assumption that your objective as an industry researcher is to develop things that go to production. So that's my assumption because I think that is what motivated me. In the past, I have been able to develop, not necessarily independently, but either being part of a team or developing some portion independently myself that went to production. And the success I found is to simplify the solutions that you develop compared to, let's say, when you're doing PhD. In PhD, or when you're a pure researcher, developing something fancy and something very elegant mathematically and theoretically is the more important part. I think when you're trying to send something to production,
Simpler is better.
well, so I would not say necessarily simpler or is better, but in both cases, what I have worked on was not replacing an existing production software. So I was not proposing, or my team or my project team was not proposing to come up with a completely new control architecture. So like we're going to do reinforcement learning and MPC to replace adaptive cruise control or something like that. That I don't see those type of things going into production. But what can work is, let's say you are developing a safety filter that would, for example, monitor the situation like a control barrier function type of safety filter. It could be a different method that monitors the perception map around you. And then if things are going like looking like some of your safety constraints are going to be violated, only then you act to modify the existing control output. So when you work on something like that, then you don't really have to replace the existing architecture. You're just adding a block that, goes on top of what it already exists and is kind of a supervisory type of block. So those type of things, then your production counterparts are going to be more receptive to take those type of things. And similar to another example would be a recursive least squares estimator to provide estimates that go into an existing block or architecture. In my experience, I have found difficult because I have always worked on problems where there was already an existing controller or an existing software. Versus if you're working in a completely new domain, maybe the answer will be different.
Makes sense. Yeah, that's really interesting. They're reliant on the assumption that in an industry setting, you want to put something into production. I think what sort of simplifications you need to make, and whether or not you need to improve something versus start up from, build up something new from scratch. I think it will change your approach accordingly.
Yeah. Trish, I think this is a very interesting topic. If I may add a couple things that, as we are speaking, that come to my mind. I have also found, especially in organizations that separate research and product development, and if you're on the research side, even if you are doing everything I told, like let's say you're building a recursive least squares block that's going to feed into an existing architecture, at some point when the advanced development phase is done, that block that you have created needs to be owned by someone in product development. So you will not be maintaining, or you will not be even calibrating necessarily, because assuming you're working in a big company, that software is going to be deployed in different products with different dimensions, and then your software will need to be tuned differently per different program. So then one challenge I have faced is you as your advanced development team might be very familiar with the algorithm or the controller that you're building, but the owners in the product development side will not necessarily have that expertise. So then again, it comes to what you have said, the simpler is better. I have seen sometimes you will deliver a block to product development, and then the end product will look extremely different and way simpler than what you have delivered. So
Yeah.
yeah.
Thank you for the detailed insights and again, reflecting on your experience. I'd like to shift topics to reflect more on your recent experiences in the advanced driver assistance systems domain and the automated driving space. In your new role, you have an increased visibility, I think, to what's happening within your organization, but also more broadly in the domain of automated driving and innovations in advanced driver assistance systems or ADAS systems. So with that increased visibility and perspective, what do you think are the current trends in that space?
Yeah, very good question. I will make a blanket statement that, I don't want to pretend like I'm an expert. It's a huge field, huge domain. I will just relay my observations. People might disagree or agree. There are, if I may speak, I guess, as if we are in a bar and having a conversation, I think anybody who's following the trends in this domain will potentially agree or have the same observations. But I think one thing, looking back, if you take the clock back 10 years ago or 8 years ago, I think that was kind of the beginning or like still rising portion of the hype cycle when it came to self-driving. I remember like even CEO level, people were talking about removing the steering wheel from all vehicles that are sold in the US by 2020. Like, I mean, I remember this very specifically. And so from that regard, self-driving was kind of even a cost saving, among other things, because you will not need the steering block anymore. Now it's 2024, and I don't think that's going to happen in anytime soon, at least when it comes to, vehicles that are sold by OEMs.
So you're
More.
not going to stand on that claim and say that by 2040 you're going to remove a steering wheel in the next generation of cars?
No, I mean, so I would never make those type of statements. I think it's very dynamic field. It's very hard to predict what's going to happen even in a year from now. But my role is different. There are some people who are viewed as trendsetters. I have seen similar things, similar statements in electrification as well. Like I think I remember hearing by 2030, every vehicle sold globally, everywhere in the world will be electric. And I don't think that's going to happen. And I don't think anybody's claiming that's going to happen. When it comes to self-driving, I think now that's not being talked about anymore. I think the focus, I think the mantra was, let's just work on solving the L4, L5 autonomous driving. Like we don't need evolutionary or incremental change. If we solve the L5, we're going to solve everything. So,
For our audience here, what does maybe L5 automated driving
oh,
or L4 perhaps mean?
yeah. Sorry about that. So level 4, level 5, maybe most of the audience might be familiar. There are different levels of autonomy that have been defined by Society of Automotive Engineers. When I say L5, level 5, that's the most advanced stage of autonomy. That means that the vehicle under any condition, so there's a concept called operating design domain, which defines where the vehicle is operating. And level 5 autonomy is saying wherever you're operating, as long as the vehicle is in a drivable condition, it will drive itself to anywhere you want. So I will just maybe as a user, I will maybe select the destination and I will not do anything else. Versus level 4 autonomy is so it has some restrictions on the operational design domain. Maybe it will only work in a certain neighborhood, but it will still provide the full autonomy as long as you are within that neighborhood. So that's the type of thing that Waymo and Cruise and other self-driving robotaxi companies are doing. Um, but from an OEM perspective, I think OEMs have realized that that's not the way to profit. Like it's going to take longer to realize that dream. And instead of focusing on level 4, level 5 autonomy, let's start to take this from an evolutionary perspective. And maybe instead of focusing on self-driving, let's focus on assisted driving. So then level 2, level 2 plus as they call. So maybe you're familiar with systems like Blue Cruise or Super Cruise or, highway drive assist for Hyundai vehicles. So basically, you're on the highway. You don't need to hold the steering wheel. You don't need to, control the accelerator or brake. So your car will drive, even do assisted lane change or automated lane change for you in the highway. But it's not. It still requires you to watch what's going on in the road, and there are in-cabin monitoring systems to make sure that you are watching the road. So, but I guess the point is now the trend, I think one of the biggest trends is hype cycle is kind of over, or like it's in the decreasing, more enlightenment region, and
Grounding to reality a little bit, right?
grounding to reality, exactly, and focus on assisted driving with evolutionary increases in the capabilities. This way, also, you are establishing public acceptance, like safety. So, as more people start using assisted driving, maybe the public acceptance also is going to increase over time. And then you can slowly build up towards a fully self-driving future instead of jumping to fully self-driving future immediately.
And so you give us, sort of your response to the current trends in automated driving, right, and ADAS. Based on that, what would you like an average person, and by average person, I mean someone who's not working in this field, to
Hmm.
consider or to know about regarding automated driving technology now and in the near future?
I think the spectrum of people in terms of how they think is very broad. It's very hard to so like I have my opinions, you have your opinions. One thing we did not, I think one thing that we didn't touch upon when we talked about the trends was safety also. I think I touched a little bit in terms of public acceptance, but you may remember the cruise accident that happened. So I think in the eyes of the average person, maybe for one reason or the other, the average person might think they either don't trust a self-driving system, they will never trust it, or they will never have the need either. Some people just like to do things on their own. Like some people like manual driving. I think most of the average, when I talk about average people, I have a lot of friends outside of the domain of engineering, and I meet people that tell me they don't even like to use adaptive cruise control. I mean, which is one of the simplest and most convenient features. Um, and I understand, I think, if you focus on the safety aspect and you hear on the news, there was an accident and one person unfortunately lost their lives. It's really a sad story to hear, and it kind of impacts the perception of self-driving. But I think maybe the average person, the only thing I would recommend in this is, we have accidents happening very frequently. And the idea of self-driving, I think, is, you're training the software, you're building this model that can drive a car, and it's being improved over time. So the same software is being improved. It learns from past mistakes and past glitches. The software is basically continuously improved and it's driving millions and billions of miles versus when humans drive, we have 8 billion people in the world and a child learns driving and they start from zero. So like the humans' capability of driving overall as a population is not really improving because we have new people starting to learn how to drive and entering the traffic. And people who are good at driving, eventually they stop driving. So there's this continuous cycle. Then eventually the capability of humans remain the same versus self-driving software is being improved every year or every second, I should say. Um, and the safety of the overall domain is going to improve over time.
That emphasis on continuously improving safety of such automated systems is, I think, something to sort of think about a little bit more or reflect upon more. And the or the upper limit is something that is constantly being pushed, and
Right.
hopefully that reaches a point where it is exceeding that of the human population, and to the point where it gets accepted. Then, right?
Yeah, I agree. Another thing to consider maybe is, again, maybe we're diverging from average person, but these self-driving vehicles, we're talking about instrumenting with, tens of cameras, radars, ultrasonics, maybe LiDAR. Like they are able to see way more than a human can see with their two eyes and two ears. So like from an awareness perspective also, the capability is way higher than a human. So the potential of self-driving is huge, but it's a system that's being improved, and we'll see what happens in 5 years. Coming back to predictions of um, 5 years.
So, Doan, in closing, I'd like to get your thoughts on one more question, which is, in such a dynamic field, what are your perspectives on how modern controls has impacted and can further improve the state of the art in automated driving?
It's an interesting question, Shrestha. So me being from control background, I am, especially now that I am leading a team that's more holistically developing, advanced driver assist systems. So I would prefer if controls was more in the center stage, but unfortunately, I think that in the self-driving domain or advanced driver assist, it really is perception, I think is the challenging part. And it is, every control system works on feedback. So that means in the self-driving domain, you need to be aware of the objects around you. You need to be aware of where you are, um, and what type of objects that you are surrounded with, and how can you plan your maneuver to reach your desired trajectory. So all that, I feel like controls is not necessarily playing a center stage, but in my experience, and like I mentioned, everybody has a different experience when it comes to controls. I have not done much when it comes to model predictive control, for example. MPC is one modern or recent, relatively speaking, control approach that has been used in planning and control for self-driving. I will come back to what I have said in terms of safety. Um, I think a lot of because of the safety aspect or safety being very important, one critical aspect of advanced driver assist is to have redundancies. So, for example, you have a higher compute perception system that may depend on cameras, LiDAR, so on, and that's the primary path. But if something fails in that primary path, you need to have a backup or secondary redundant system that uses different sensor modalities and potentially kicks in when the primary path is compromised somehow. And again, I will come back to maybe not necessarily control barrier functions, but some kind of a safety filter that monitors the environment, monitors what you are doing, what the control signal is, and what the feedback is, and what the obstacles around you are, and formulates certain constraints, and then monitors those constraints to be satisfied. And if there's violation, acts to modify. So reference governor is a similar idea. I think action governor is a similar idea. Control barrier function is a similar idea. I have seen on my experience, those have been the most prominent, or those have been the most intrusive in a way when it comes to being applied in self-driving or advanced driver assist systems from a modern control perspective.
I see. Makes sense. Yeah, that's a very fascinating take on how we can sort of leverage these constraint optimization tools, for example, in where what is, like you said, a more perception dominant or perception heavy technical area.
Yeah, but when I was thinking about control, I was thinking even like further down the line than planning. So I separated in my mind planning and control is the end part. So you have a plan, and then you need to realize that plan by actuating on steering and acceleration and braking. And I have seen control from that perspective.
Makes sense. Doan, thank you so much for your time and for your insights today. I really appreciate you being on the podcast. And I'm hoping that we can continue staying in touch and that we'll have you on the podcast again to further share your new learnings.
Thank you very much, Shrestha, for having me. It was a pleasure. It was actually fun talking about this domain. And I am really hoping to see you either in Michigan or Texas in the near future. And it was very fun talking about this. Thank you so much.